Recall from the previous video and workbook about dissociation constants of weak acids and bases. We can calculate the dissociation constants Ka and Kb by plugging in the values of the concentrations of the reactants and products in the equilibrium expressions. In this video, you will compare the strengths of weak acids and bases using Ka, Kb values, as well as pKa and pKb, and calculate the percentage ionization of weak acids and bases. To compare the strengths of acids and bases, you must remember, higher the value of Ka or Kb, greater is the extent of dissociation, and stronger is the acid or base. So for example, look at the Ka values of these three weak acids: oxalate ion, hypochlorous acid, and nitrous acid. So which is the strongest acid of the three? That is, which one dissociates to the maximum extent? Nitrous acid has the highest value of Ka, and hypochlorous acid has the least value of Ka. So we can see that nitrous acid Ka value is greater than that of oxalate, which is greater than that of hypochlorous acid. And from that we can infer that nitrous acid is the strongest acid and hypochlorous acid is the weakest among the three. You can also calculate the minus log Ka values, which would give you pKa. And you can calculate for the three acids and arrange them from the least to the highest value. And here you will see that nitrous acid has the least value of pKa and hypochlorous acid has the highest value of pKa. That means lower the value of pKa, stronger is the acid. Similarly, here are Kb values of three weak bases, and you will see that the Kb value of methylamine is the highest, and therefore it would be the strongest base, and the Kb value for pyridine is the least, and therefore it would be the weakest base. You can also calculate the minus log of Kb, that will give you pKb. And if you compare the three pKb values, methylamine has the least value, pyridine has the highest value. And from that you can infer, lower the value of pKb, stronger would be the base, and higher the value of pKb, weaker would be the base. Lastly, the extent of dissociation can be quantified by calculating percentage ionization. Percentage ionization for a weak acid given in this generic reaction is the concentration of hydronium ion divided by the initial concentration of the acid times 100. So here's an example where hypochlorous acid, which is a weak acid, the pH of the solution is given, and the initial concentration of hypochlorous acid is 0.60. And to calculate the percentage ionization, you would use this formula where percentage ionization, you'll have to put in the value of the hydronium ion and the initial concentration. So the concentration of hydronium ion is calculated, which is 8.3 into 10 to the power of -4. And the question already gives you the concentration of hypochlorous acid, that is the initial concentration, which is 0.60. All you have to do now is plug in the values of hydronium ion, the initial concentration of the acid, times it with 100, and you'll get the percentage ionization. So in the workbook, there are questions on comparing strengths of acids and bases and calculating the percentage ionization. So good luck and enjoy.